I'm Rob.
I'm Chris.
And I'm Kevin.
And you're doing Newton's third law, okay? Not the first, not the second. It's the third law.
The third one.
Okay? For every action, there's an equal and opposite reaction.
Here we are at Imagination Station. And you know, to understand physics, you don't need a physics laboratory. To understand Newton's third law, all we truly need is this physics book.
What happened there was, Rob exerted a force on the physics book, and the physics book exerted an equal and opposite reaction on Rob's hands.
Hold on a minute. If it exerts an equal and opposite force, how come Rob didn't go flying backward when he threw the book? Try again
Well,
later.
Chris, although the book does exert an equal and opposite reaction on Rob, the gravity that holds Rob in place keeps him from going backwards. Now, if we were having the same example in space as in the space station, if Rob threw this book, he would be going backwards, equally the same as the physics book. There's two examples of Newton's third law coming into play here. The first one, Chris, force pulling down on the swing, and the swing pushing up on Chris. The second example, Rob pushing Chris, and Chris is pushing Rob. A third example, Chris is pushing force on Rob, and Rob's force is equally exerting force on Chris.
Now, as Chris hangs from the monkey bars, his weight exerts a downward force, while the monkey bars exert an upward force, causing gravity. You can fall now, Chris.
I'm Rob.
I'm Chris.
And I'm Kevin.
This was our project for Mr. Audie's class. This was about Newton's third law. For every reaction, there's an equal and opposite reaction.